Hello, I'm Professor Rad, and in this video, we're going to do a little experiment. So in the last couple of videos, we talked about how you can visualize a division, right? So find a quotient that way, as well as how to check our answers. In this video, we're going to explore how we might go about dividing a bigger number when I don't want to write out, for example, 456 dots, or subtracting 4 from 456 is going to take a really long time. So how might we break this into smaller pieces? And this is what mathematicians usually do. They take a question, right? They have a definition that they know of, in this case division, and they've got some techniques. And now we want to explore, well, how could we, adjust them or alter them for this bigger value when I don't want to spend all that time, subtracting 4 one at a time. So here's what I see when I look at this and how I'm going to approach it. So I know that 456 is the same thing as 400 plus 56. This is pretty similar to when we split numbers up for the addition process or subtracting left to right. I'm just keeping this as 56 instead of 50 plus 6, and we'll see why in a little bit. What's really important to me here is this 400, because I know that 400 is the same as 4 times 100. Okay, but how do I know that? Well, I know that 4 times 1 is 4, and I know that if there are extra zeros at the end of a number, they can go at the end of the number when I multiply. So if I do 4 times 1, I get 4, and these 2 extra zeros match up with these 2 extra zeros here. So I know that in order to get the 400 part of 456, I would need to multiply by 100 to get there. Now I just have to figure out, well, what do I need to multiply to get this 56? I do know in my multiplication tables that 4 times 10 is 40. And I know that 40 is pretty close to 56, but we're not there yet. So what I'm going to do is I'm going to use some repeated subtraction in order to help me get there. So here's what that's going to look like. I've got my 56, and I know I can get to 40 by subtracting a 4 10 times. So subtracting 40 is like subtracting 4 10 times. And now 16 is a much smaller number, and I'm going to continue subtracting 4. So that's a 12, 8, 4, and 0. So this time I was able to subtract 4 perfectly, and I got 0 in the end, which means I don't even get a remainder. Let's see how many times total I would have needed to subtract 4 from 56. So when we did this 40, that was 10, 11, 12, 13, 14. So I needed to multiply 4 by 100 to get the 400, and 4 by 14 to get the 56. So let's see what I would have had to multiply by total. So we had 100, and then our 14. So that means 456 divided by 4 should be 114. Let's check our answer to see if this is right. So if I do 114 times 4, since there was no remainder, I should get 456 perfectly. 4 times 4 is 16. 4 times 1 is 4, plus 1 is 5, and 4 times 1 is 4. So we broke our pencil. We got so excited because we did it. So we got 456 when we multiplied 114 by 4. So what I wanted to illustrate here is that there are multiple ways of thinking about division of large numbers. And if you are comfortable using a variety of different techniques, then there are different ways that you can get to your solution and different shortcuts you can take. But the problem is, you don't always know what shortcut is going to be good. For example, if this had been 546 instead, then I wouldn't necessarily have thought to use 100 because I would have had a 500 here instead of a 400. So depending on what I see when I look at the problem, I might want to try and experiment with different techniques and in different ways. So in the next video, we're going to look at what's called an algorithm. And an algorithm is a process that you can methodically follow that's going to work each time. So we don't have to worry about guessing what technique will work best. So I'm looking forward to seeing you in the next video, and we will explore the division algorithm. Bye for now.